QSO Today, Episode 435, Thomas Henderson WD5AGO. This episode of QSO Today is sponsored by ICOM America, makers of the finest amateur radios and accessories for your ham radio station, and by Nuts and Bolts Magazine. Save the date for the next QSO Today Virtual Ham Expo, March 25th and 26th, 2023. Tickets are on sale now. Follow the link to the Expo website for more information. Welcome to the QSO Today podcast. I'm Eric Guth, amateur call sign 4Z1UG, where I demonstrate the diversity and relevance of the amateur radio hobby and its impact on society by interviewing ham radio operators, many of whom played vital roles in shaping our technology through the amateur radio hobby. And while many people might say, ham radio, do people still do that? This podcast demonstrates through in-depth interviews just how amazing, diverse, and dynamic the amateur radio hobby continues to be. We are still looking for additional presentations for the next QSO Today Virtual Ham Expo in March. Our theme this time is New License, Now What? If you have a ham radio subject that you'd like to share with a new ham or an old ham, please click on the banner to get to our speaker application on the Expo website. It came to my attention just before posting this episode that Rod Moag, W5NDS, my guest in episode 255, recently passed away. Rod was a blind ham, an accomplished country and folk musician, inducted into the Country Music Hall of Fame, and he loved ham radio. I was lucky to have Rod as a guest. Please go back to episode 255 to hear Rod's amazing story. He will be missed by his friends and family. May Rod's memory be for a blessing. Tommy Henderson, WD5AGO, has always found EME or Moonbounce operation on the bands above 6 meters fascinating and worthwhile, making thousands of contacts by phone or CW. Building his own EME rigs has led to deep technical expertise and ham radio success. As a teacher and now department head at the Electronics Technology program at Tulsa Community College, he uses amateur radio to enhance his full curriculum while demonstrating its utility. WD5AGO is my QSO Today. WD5AGO, this is Eric, 4Z1UG. Are you there, Tommy?
Yeah, this is WD5AGO. Thank you, Eric, for calling me.
Tommy, thanks for joining me on the QSO Today podcast. Can we start at the beginning of your ham radio story? When and how did it start for you?
Well, I always liked building things. I mean, I had the Cox engines for airplanes, had the erector sets and things like that. So I was always curious about building. I like slot cars and that type of thing. But one time I saw an article on how to build a crystal radio. So I went to the nearby Radio Shack, picked in, I believe, a 1N34 crystal diode, a crystal earpiece, 2 wires, no tuning circuit, just took one end to a grounded pipe, the other end to a screen on the windowsill, and I picked up the local radio station. No tuning, just directly earphone across the diode. And I thought, this beats everything else I ever did. I mean, that was it. And I knew I wanted to do electronics. And so within that next year, I heard about CB radio and ham radio and proceeded to get my license while I was in 9th grade. I studied code during history class. I cut out the paper, had all the dots and dashes, lay them in the book. I studied that. That's how I got my code up to 5 words.
Instead of paying attention to what was going on in the classroom.
Yeah, I didn't do that. Only thing I did good in school is electronics. So,
what was the hometown? Where'd you grow up?
Sand Springs, Oklahoma. So I'm fairly close to home from here.
When did you discover the germanium diode detector and the window screen?
It was in a book. You bought one of those 101 electronic project books at the bookstore, and I saw that and thought, I'm going to buy that book, and took it home. I had all these projects in it, and they showed just taking the diode and did exactly what it did and picked it up, and no battery, no nothing. I think that was what was cool about it.
Was your family into projects?
My father's mechanically stuff, so engines and cars, but really nothing to do with electronics. So I was kind of a lone gun on this adventure as far as electronics is concerned.
So the hometown was Sand Springs, Oklahoma. You got your first license in 9th grade. Would that make you, 15 years old?
I was 10th grade. So I got my license in 10th grade. I started studying in 9th grade.
I see. So you were 16 years of age?
Yes. See, yeah, I just turned 16.
Would you remember your first call sign?
It's the same. I've had the same one the whole time.
Really? Oh, that's cool. And you haven't felt to vanity call or upgrade it?
No, I mean, now I've published so much stuff and things, it just seems weird to change it. So, and people know me would always ask, why did I do that? And I thought, I'm not even going to bother answering that. I'll just leave it alone.
Did you have any mentors or Elmers to help you along?
Yes, I had a friend there in the ninth grade that said, hey, my grandfather and father are hams. And I said, okay. So I rode my bicycle to their house about 3 or 4 miles away and went to look at all their stuff. And those guys was Ray, W5HFV, and Larry, W5UGO. Now, both of them obviously passed on, but they kind of nurtured me along a little bit. They were more into VHF, which I didn't really understand at the time. And then when I got into 10th grade, we had an amateur radio club at the school. So in my high school, you had 2 years of electronics you can take. So I took 10th grade and 11th grade electronics, and my instructor was a ham operator. His call sign was WA5SPB, Jim. He's obviously gone too. And then I had one more year in my 12th grade year was another fellow by K5FQS. His name was Richard. He's also passed away. So all 4 of those guys did a lot of help with me getting my license and talking and things like that.
And the first license, was it a novice license?
Novice, yes. I was novice for not quite a year, and I moved up to general.
What was the first rig?
It was a Swan 350.
Whoa. How about that?
Yeah, about that rig. That thing got me in a lot of trouble. I think I got 2 or 3 pink slips with that thing saying I was out of band or causing interference somewhere else. It drifted like crazy.
And it wasn't exactly a crystal-controlled radio for a novice.
No. We didn't have, I think the rules had just passed a year or 2 earlier that you didn't have to use crystals for a novice.
The Swan, as I remember, took a long time to warm up.
Yes, it did. Yeah. And so when I get the pink slip in the mail, I would say, hey, I'm 16 years old. I got a Swan 350. I am working to redeem the problem. I never heard from him again. So.
In the novice band, you had 80, 40, and 15 meters, and that's what you operated on as a novice CW?
Yeah, and we had 10 too, but the Swan didn't cover that without crystals. So, yeah, it was I spent most of my time on 40 and 15.
CW. And you liked it, I guess.
I like CW.
And then what happened after that? You upgraded to general the following year, and then where did you go with that?
I pretty much did the same thing. I did a little bit of phone, but mostly CW. And then let's see. Then my senior year, I was doing the same thing, and then I kind of let that go for about a year because I got interested in racing. So picked me up a 70 Chevelle and went to go drag race it. And then about 1980. I picked up a 2-meter sideband rig at a Hamfest. And I thought to myself, there's nobody on 2-meter sideband. I took it home, hooked it up, and there was people on 2-meter sideband. Although this is kind of weird. I thought 2-meter was just FM. So I built myself a little Yagi antenna and put it up on the house and started working people in a 5-state area. I thought, this is actually kind of neat. And worked some E-skip and some trope openings and things like that. And then people in the air said, hey, there's a such thing as EME. I go, I don't know anything about EME. So I picked up the iMac EME notes. At that time, you can get them from Bob Sutherland, W6PO. He worked for them, and he made these notes. He started in the 70s, and he would send those to you. And I still got them this day, and I would read those back to back till they were falling out of the book, and studied the antennas and bands and all that stuff. And I knew that at that time, that's what I wanted to do, was get on EME. And that was in 1980.
Did ham radio play a part in the choices that you made for your education and career then?
I'm going to say I was already interested in electronics first. Ham radio supported that, and most of my projects were directed toward ham radio, but I just like electronics in general. So I dabbled in a lot of different types of electronic circuit.
Professionally, what happened to you after high school? What did you do?
I went to a company here locally, hired me right out of high school, electronics, and I worked for them, and then I worked for a mobile phone company, working on pagers for about a year. And then I left there to go work for a place called Telex, and I was at Telex for 11 years, working in electronics. And then that company shut down, and my wife said, you know what, you really ought to go get that degree that you've been wanting to get. I go, yeah, I guess it's that time. So I started school when I was 30. I might as well get a degree that says something. So I got myself an associate's in electrical engineering technology, and thought, I'm good with that. She says, yeah, you won't be satisfied. So she was right. Went ahead and got a bachelor's, and started working for schools because a friend of mine called me. Again, it's my same one from my high school instructor, said, hey, I think you'd like teaching. I said, really? And I said, yeah, okay. So I tried it, and I really like teaching. So been teaching now for 30 years.
Okay, and so you went to go back and you got your Associates of Electrical Engineering Technology from where?
Tulsa Community College, where I teach at now.
And what did you like about teaching? Did you stay one chapter ahead of the students as your...
I started out, I think I did that. I started out with high school electronics. I taught at a VOTEC here for 4 years, and then and I was getting a lot of those students interested in amateur radio and things like that. But I think the level I wanted to teach at was not the same level they wanted to learn at. And so a friend said, hey, we have an opening at the university. And I said, well, I don't have my degree in that. Well, come down and interview anyway. So I went down and interviewed, and they hired me to be their electronics and avionics instructor. So so I went to there and was there for 3 years, and it was quite a drive. It was at Oklahoma State University. And then when this one here came open, I took that one because it was closer to home. So I've been teaching at the college university level since then.
Let's go back. I'm interested just for a second in the stint that you did with radio pagers. What were you doing, and who were you working for?
It was a company called Mobile Phone, and they had two-way radios and also carried pagers. And the pagers then you had two options. It'd give you a 7-second
voice message.
Yeah, or just the vibrate.
The Motorola Spirit pager.
Yes, that's it.
Pageboy 2.
Yeah, Pageboy 1 and Pageboy 2.
No, I had a pager repair company in the 80s.
Is that right?
Thousands of pagers.
Well, I'd get so bored that, I'd had to call and test them, right? I tell this story to my students. At that time, Mr. Bill was really popular, and I watched a little bit of Saturday Night Live because that was my favorite cartoon. And so I made Mr. Bill episodes on the pagers. So I'd say, hello, Mr. Bill, it's Pluto. I'm wanting to come over to your house or something like that, right? And I would hang up, and I had episodes going on when I did these pager tests. Well, one day, somebody came in and dropped all 30 of their pagers to the front desk, and they said, why you return them? These things keep going off in our meetings with some knucklehead screaming something about Mr. Bill. Well, I didn't realize that day, the one that I had, it was connected to 30 other phones on the same phone number.
I see. Yeah. They all had the same paging tone combination in them because it was a group call.
Yeah, well, they were in their meeting. All of them went off, and yeah, I was told not to do that anymore.
Just briefly, I guess we've done mobile phones now for so many years that we somehow forget that there was this evolution of consumer radio technology for communications, from the taxi cab radios and two-way radios. But in terms of consumers carrying mobile radios, the pagers were really the first thing, and the whole interconnection with the telephone system. And it was a very interesting period of time. And who would have thought that we'd be at the point now where we're carrying around the Encyclopedia Britannica or even more, on our hips. But at the time, it was an interesting thing.
And the phones were crazy. The phones we'd install in the cars, these big headsets, the Motorola, this big obnoxious thing would sit in your trunk. And I remember one time, Roy Clark, which was a famous guitar player, he came in with his Rolls Royce and wanted to have that put in. And they said, we're going to drill and put a hole here. I don't care. So there's like 2 layers of steel. And I said, well, I didn't say anything. I was young. I was like 19. But everybody was talking about, you sure going to put that hole there? Better be in the right spot because we can't fix this if you mess it up.
And now this message from ICOM America. ICOM wants to wish you a Happy New Year. If Santa confused your wish list with that of someone else's, and a new battery-powered weed whacker is displayed under your tree, then it's not too late to return the mistake and head to your favorite ham radio dealer for one or all of the latest ICOM transceivers. The ICOM IC705 is the perfect sidekick and QRP companion with base station features and functionality at the tip of your fingers in a portable package covering HF 6 meters, 2 meters, and 70 centimeters. This compact rig weighs in at just over 2 pounds, with RF direct sampling for most of the HF band and IF sampling for frequencies above 25 megahertz. It has become the go-to baseband rig for microwave operators. Its features include a 4.3-inch touchscreen display with a live band scope and waterfall, 5 watts with a BP272 battery pack, and 10 watts with a 13.8 DC power supply, single sideband CW, AM, FM, as well as full D-Star functions, a micro USB connector, Bluetooth, and wireless LAN, integrated GPS with antenna and GPS logger, a micro SD card slot, the HM243 microphone speaker is included, and it supports QRP and QRPP operations. The perfect accessory for the ICOM 705 is the optional LC192 backpack. The LC192 includes a special compartment for your IC705 and additional room for accessories. The ICOM ID52A is a VHF-UHF dual-band handheld portable transceiver with D-Star and FM dual-mode functions and is the first handheld amateur radio with a full-color 2.3-inch waterfall display. This portable supports conventional FM communications and D-Star simplex, repeater, regional, worldwide calls over the D-Star Internet Gateway. You can even send photos over D-Star using your connected Android device. Other ID52 features include a wideband receiver with guaranteed range of 144 to 148 MHz and 440 to 450 MHz, VV, UU, VU with dual DV mode, integrated GPS GLONASS receiver including grid square location, micro SD card slot, micro USB for data transfer, programming, and charging, and of course, it is in an IPX7 waterproof case. The ID52A is the perfect companion to the IC705 as both use batteries, headsets, and the same Android app for D-Star operation. Create your own band opening with the ICOM IC9700. This transceiver brings direct sampling to the UHF-VHF weak signal world and is loaded with innovative features that are sure to keep you busy, including faster processors, higher input gain, higher display resolution, and a cleaner signal. More features include a 4.3-inch touchscreen color TFT LCD with real-time high-speed spectrum scope and waterfall display, smooth satellite operation with 99 satellite channels, dual-watch operation, and full duplex operation in satellite mode. The ICOM IC7300 is a high-performance HF transceiver with a compact design that will far exceed everyone's expectations. This transceiver digitizes RF before various receiver stages, reducing inherent noise in different IF stages. The IC7300 changed the way entry-level HF is designed. The ICOM IC7300 features include RF direct sampling, 15 discrete bandpass filters, large 4.3-inch color touchscreen, real-time spectrum scope, and an SD memory card slot. This radio by far is the best HF rig that I have ever owned. I love it for its features and value. When it comes to amateur radio operators justifying a new transceiver purchase, Santa's confusion is one of the best explanations to your significant other, that you're only correcting Santa's embarrassing mistake. 2023 is just beginning, and there's no reason not to enjoy a single day of the new year operating your new ICOM transceiver. Head out to your ICOM dealer today to purchase your new ICOM rig. Be sure to tell your dealer that you heard about it here on QSO Today. And now back to our QSO. You're a teacher now in Tulsa, and as we established before we even began the recording, the program that you have might be unusual. Could you talk a little bit about the program that you have at your community college and how you teach students about electronics and ultimately amateur radio?
Sure. I'm over all the electronics. I cover electrical power, which is the substations, basic semiconductor theory, biomedical electronics, and alternative energy. And then, of course, these, and also the EET, which also transfers to the university. So I work with the university also. And it's basic, component level training. And we have an amateur radio club there at the school. We've set up EME array there and basically a HF station also.
And how many students do you get through your program that'll have the hands-on experience with the radio equipment?
Somewhere between 50 and 60 a year. And out of that, maybe 10 of those will get their amateur radio license.
And do they become active hams as a result of being through your program?
Some do. I would say majority don't. It's really difficult to follow, although I do get feedback from some of them that have went on to done something with the license, but I'm afraid that a lot of them don't.
And why do you think that is?
Well, I put a lot of pressure on them. I give extra credit to get the amateur license, things like that. I make it part of the course. I have a course on wireless communication, so part of that is they can either pass their amateur license or pass the FCC license, because I also have an FCC radar endorsement license, so I give them the opportunity to do either one of those.
And what do they call that now, the GROL, G-R-O-L license?
Yes, yeah, GROL, yes.
That has endorsements for radar and things like that, or is it just general now?
You have the general, but you can add a radar endorsement to it, so it's an additional test.
And is that endorsement still required by law for you to work on a ship or something like that, to work on a radar?
No, I think just the GROL is all that's required. I think the radar signifies that you have that ability to do that. I'm not quite sure that they actually require you to have that anymore. I know the television stations require it, but I'm not sure anybody else does.
They require the radar endorsement?
No, just the GROL. Just the
GROL, okay. I'm curious, we can talk about this, and we talked a little bit about this, but why do you think that the majority of the people that would get licenses, they have so much experience and hands-on with you, why do you think they don't become active?
I still think as a lot of it, they don't understand it. I can get them in the classroom and show them contests and things like that. And one or two will get into it, but most of them are going, why are you doing that for? So, they don't get the bug. It's really difficult to explain why somebody likes something and why a group of people do not. But I can go get an Arduino and say, here, let's build a robot. And this whole group that did not really want to be a part of the radio would want to be a part of that Arduino project. So it's just the desire of this is what I want to do and this isn't. It's really, really, if I could figure that out, I could probably recruit more students.
Once they leave your course or they leave the community college, do you think that they will take the Arduino and become an Arduino hobbyist after that? Or do you think that, like with the amateur radio license, they won't hobby it afterwards?
Majority of them that do leave with the microprocessor training and things like that liked it, I find a lot of those students will still do that.
That should give us some kind of clue.
Yes. Yeah, that's what I'm saying. It's a hard fit. Now, on the alternative energy side, though, we've had projects with wind turbines and things like that, and I find the students want to do that. So it really is. It's a hard draw on what interests the student right now. But whatever it is, if it makes money or it helps them get a job, that's what they're looking at.
That kind of makes sense because that's kind of the role of the community college, I think, is to train people to work. It's job training. So you got the EME bug, or you got the VHF bug. Can we talk just a little bit about 2-meter single sideband before we move on to EME? Is 2-meter single sideband still active? Do people still do it? And what are the opportunities on 2 meters that's not FM, or 2 meters and above, for example, in terms of modulation schemes and opportunities for either making contacts or experimenting?
Well, there's still people on 2-meter sideband. I can get on and talk to some locals, although the amount of traffic that's going on is not near as what it used to be in the 80s and 90s. It has fallen off a little bit, and it's probably fallen off more since digital has really come of age using WSJT and other types of packet type of data transmissions. So, but whichever one you choose, whether it's single sideband, CW, or digital, the modes, there's several modes that people use, and really, meteor scatter is really good for all three of those. You can send a lot of data in a meteor trail. It may last anywhere from a second or so, maybe several seconds. And you have Aurora. Aurora, you bounce signals off the what calls the northern lights. And you have basic tropo, which is it usually has to do with temperature inversions. Here in the Midwest, we get quite a few trope openings, either down south or back east. So there's several modes on 6 meters and 2 meters that you can surely utilize with the weak signal modes that we have.
And what kind of equipment do you need for that? If you're going to operate 2 meters non-FM, so you're not buying a mobile FM radio, what would you be buying now in order to operate CW or single sideband or AM or some of these other modes?
I'm not sure of the newest radios. I mean, I still use an ICOM 706. So that was I believe a 25 watt. I think it does 25 watts on 2 meters. It's in that range. It's like 100 watts on 6 meters, 25 to 50 watts on 2 meter, and 20 watts on 70 centimeter. But I know there's some other rigs out there that are a little bit higher power. So let's say you had 50 to 100 watts on 2 meter. You can make several 100-mile contacts on that power level in a decent antenna.
And a decent antenna on 2 meters would be a Yagi antenna, 5 elements?
Yeah, 5 to 10 element Yagi.
Horizontally polarized.
Yeah, almost everybody's horizontal. And that has to do with the noise. You have less noise pickup horizontal than you do vertical.
Whereas with FM, for example, we use vertical antennas because repeaters and other base stations are vertically polarized.
Right, yeah, because it's easier to erect on a tower. A 5/8 wave or a expanded collinear antenna is usually vertically polarized.
There's a lot of your QRZ page dedicated to EME, and then when we do a Google search on you, then there's a lot of returns on the EME side. So you got interested in EME right out of high school. How did it proceed? It seems to me that EME is probably one of the most challenging aspects of amateur radio in terms of making successful communications. How did that evolve, and what success did you have?
Well, it seemed to me it took a long time. I built my own first 4 Yagis. They were Quaggy antennas. I think it's like a 10-foot boom Yagi. And then I went to 6 of them, and I heard stations, but I never made a completed QSO until about a year later, and I went with 4 commercial Cushcraft. At that time, they were called a 3219, 19-element Yagi, like on a 21-foot boom. I had 4 of those phased together. And recall, this is on a city lot, so I'm living in a garage apartment on a city lot. And my landlord lets me put up this tower hooked to the next to the house with this antenna on it. And there's no concrete in the ground or anything. I'm basically using 2 of those brackets you nail against the house to hold this antenna up. I wouldn't advise doing that. But anyway, I just did stuff like that back then. And I had this array up there. And finally, with 300 watts in that Yagi, I finally worked K1WHS in 1982. And I tell you what, that was it. I found my new calling. That mode of operation, just, I don't know what about it was so cool. At this time, I couldn't hear my own echoes yet, but that would come later. But that mode was really interesting.
Now, there might have been a learning curve on how to create a phasing harness, essentially pieces of coax cut to exactly the right length to go between the various antennas so that those 4 Yagis would work together. Was there a learning curve on how to make that whole antenna array work for you?
Yes, there was. I mean, I would look up charts on how to transform the impedances, so we know that whether you phase with a half wave line or a quarter wave line. I'm going to use a quarter wave line. Those 4 antennas would come down to 12.5 ohms. You'd step up 12.5 ohms, 50 ohms, and I get get this, though. I didn't understand any of that stuff what I'm talking about now. I look back now and go, oh, that's what it did. So it's taken several years later to figure out what I was doing, what I knew what I did then made any sense. But yeah, I just did what people suggested. I used to make my own half-wave line and made equal lengths of coax going to that what we call a power divider. And, you just hope it worked. I mean, I don't think I had much test equipment back then.
I want to take a minute to tell you about my favorite podcast, the Ham Radio Workbench Podcast, with George, KJ6VU, and now joined by Rod, VA3ON, Mike, VA3MW, Mark, N6MTS, and Vince, VE6LK. Every 2 weeks, George and company offer up a status report on the many amateur radio projects on their workbenches and explore projects on their guests' workbenches. This group is project active and prolific, covering many technical areas of amateur radio. So the next time you want a deep dive into ham radio electronic project building, or to learn about technology, tools, test equipment, construction techniques, and the rest, listen to the Ham Radio Workbench podcast, available on every podcast player and channel. Use the link in this week's show notes page to get to the Ham Radio Workbench podcast directly. And now back to my QSO. We're talking on Zoom, and Tommy has a beautiful array of microwave test equipment. I think I see a spectrum analyzer and a signal generator, right?
Yeah, signal generator to 10 gig and a scalar analyzer, a scanner and a vector analyzer.
So now all of this job is made much easier than it would have been then, because it was more or less trial and error for you then in those days, right?
Right. You just hoped it worked. I mean, and I think I had a preamp. It was a AR squared. I don't know if that company's still in business or not. But I didn't know how to build one yet. So I used it and a single tube 46250B amplifier, did about 300 watts. But after that, I decided, everybody said, you just really need more power. So that took on a big learning curve of learning how tubes worked. And so I built a 2-tube amp, 46250B, and I built the 2,000 volt supply, and I had wire just running across the kitchen floor to the V plus. I mean, literally just laying across there. It was great. And I tuned that thing up, and I noticed that I just had a plexiglass cover over the top of it. I didn't know anything about tank circuits that much, like it's radiating on you. And I noticed how the purple haze was happening inside the structure of those ceramic tubes. I thought, hey, that's pretty cool looking. As I'm sitting there watching the purple haze, later you realize that was some bad RF radiation you were absorbing. But you just don't think about those things at that time.
No, when you're young and immortal and you're climbing that tower that's connected to the side of the building with 2 lag bolts.
Yes.
You don't think about gravity or anything like that.
Those were good days.
Yeah, those were great days. I remember those. It says on your QRZ page that you've worked thousands of contacts, but that you have done none of them using digital modes, that you're using CW or phone to make those EME contacts. Now, I remember interviewing somebody once that said in those olden days, and maybe they were talking about, meteor scatter and not EME, but that they would actually take their CW, they'd put on a tape, and they'd speed it up to send it across so that you could capture the message in the window. Did you do anything like that in order to be able to make those contacts, or do you just get there with your key or your bug and you just send CQ and get a reply back?
I had heard of people in the 70s doing that with meteor scatter, because a meteor scatter trail can be, again, as short as a second or two and as long as maybe 10, 15 seconds. And that's a rarity to have one that lasts 10, 15 seconds. Most of them are a lot shorter, so they would practice that high-speed CW doing that. On EME, you can send fast, but sometimes the fading will make it choppy. If you send super fast, if you send super slow, then it can break it up. So there's a comfortable speed with EME. I believe it's somewhere between 10 and 15 words a minute. So I operate somewhere between 10 and 13 words a minute on EME.
Do you use a straight key or do you use a bug?
Well, believe it or not, it wasn't until after I worked WAS on 2 meter. It wasn't until sometime later that I still use a straight key. Now I use a a keyer. But I used a straight key for probably 2 or 3 years.
You worked WAS on EME?
Yes. Not all the contacts were EME, but a lot of them were.
Are there a lot of EME operators these days?
There's a lot on as you move up. If you're going to look at 2 meters and 70 centimeters, there's more people using digital modes now. And if you look at maybe 23 centimeters and above, it's kind of half and half. And as you make your way up to the higher microwave frequencies, I'm going to say there's probably still more on CW than there is on digital. 23 centimeters, I'm going to say it's probably about half and half.
Now, are the people that are operating, say, in 2 meters and 70 centimeters, and there's no EME on 220 megahertz?
There is. I've made a couple of contacts on 222, but that's not what I call an active band, because really only people can operate in South America, North America.
I see. And do you have to kind of post on some kind of reflector somewhere that you're going to make a contact and for people to pay attention?
Yes. There's usually a group that says, hey, we're going to get together and go to a state or something, and that'll kind of get some activity going.
They call that spotting, right?
Yes.
And do you find that the more people, or maybe the newer people that are operating digital modes on VHF and UHF, are they running the power, and are they using the antenna arrays that you used in order to make your original contacts? With the digital modes, do they need that power and gain, antenna gain, in order to make those contacts?
From what I understand, I'm not that familiar with it because I don't use it, but they say that it's easily to 10 to 20 dB below what you could hear naturally. There is some advantages using the digital modes, so that would reduce my antenna size. So let's say I need 4 Yagis for CW. I could probably get away with 1 Yagi if I was using the digital mode and with less power.
That means that as an opportunity for hams to get on to do Moonbounce or EME, then they don't need to have the elaborate station that you operate now for CW or phone.
No, it can be a lot smaller. But on the other hand, though, a lot of the hams may be losing part of the art of designing that better amplifier, designing that bigger array, or designing that lower noise amplifier. So, there's always a give or take. One's becoming more of an operator type of communication, where the other one's is more of a designer type of communication. So where if you design the whole system, it required more power, more antenna, but usually designed all that where if I choose to go the other way, I can, and I use more of a ready-made antenna, standard transceiver, maybe a solid-state brick amp. Yeah, I can make those contacts too, but I don't have to put as much theory into that operation other than setting up the computer.
I'm trying to see whether or not EME at this level with the digital mode could be like the gateway drug that gets people into EME and then potentially into doing VHF and above and microwave, eventually getting to the point where they're saying that, if I spend a little bit more time on learning about transverters or preamps or power amps above 70 centimeters, that would give me that extra kick that I need in order to be able to get WAS on 900 megahertz or something like that. Is that possible?
Yes. And that's the angle I'm using with the students. I don't require them to learn CW. I think it's difficult. It's difficult to get somebody to sit down during your history class and study the code and things. It's an opportunity if they want to learn that. But to me, it's a lot easier if the students would do these VHF and UHF frequencies, and they want to do Moonbounce or want to do some of this more exotic type of communication, is to use the digital mode. And we have a group that I also teach at Oklahoma State University part-time, and we had an engineering group over there just finishing a Yagi array for their senior project. And we used 432, and they're using a digital, all digital, because now no code. But there was no way for them to make an EME contact because they don't know CW. So I encourage them highly, hey, let's get a computer hooked up, and you need to download the software, and let's try digital. So no, it's very good for our younger folks to know that that's out there available.
When you go above 70 centimeters in terms of frequency, if you go 900, 1.2 up to 10 gigahertz or whatever. What are the opportunities to do EME on those bands? Is it more difficult? Is it easier? What is your sense? Because you've done it all.
It probably, I believe, at one time was more difficult, but nowadays there's more transverters available if you want to go that route. And right now, the hottest band is really 23 centimeters. That probably has the most people on it. That's what I call a variety of either CW operators or digital operators. So it has more opportunity. And that's the band I went to after in 1985. I was getting so much TBI complaints on 2-meter EME that I had to get off of it. So I had to leave 2-meter EME. I thought about 432 EME, but I thought, what the heck, let's just go to 1296. So in 1986, I got on 1296 and purchased a 13-foot dish from a local cable company that was throwing it away. So I got it for scrap price. At that time, I was building my own LNA, so I built my own LNA. I built up a 100-watt amplifier from the tube. That was great. You could hear your own echoes with that small system on 23 centimeter.
A 13-foot dish might be hard for some people to get these days, but can you still buy an 8-foot dish? It used to be when the TVRO business was big and people were buying satellite television that you could buy the 8-foot dishes.
Yeah, with the noise figures we had at that time, there's people that can make a contact with an 8-foot dish, but it was a lot more on the thin side. But nowadays, the noise figures are a lot lower. When I first started, the noise figures were about 0.7 dB for a 1296 LNA. I build LNAs that are below 0.3 dB noise figure for 1296, and others do too. It's not proprietary. It's not that hard to get below that noise figure anymore. So that increases that helps your signal noise ratio. The feed horns are more efficient. We know how to build a better feed horn now than we did back then. And you have solid state amplifiers now that can easily do a couple hundred watts. So it is easily done with an 8-foot dish now on 23 centimeter.
And as you go up in frequency, if you go into the 2 gigahertz or 5 gigahertz bands, what does that look like and how much activity is there?
I've been on 2304 for the last 13 years on 2.3 gig. In the beginning, I thought it was okay, but as I perfected the equipment, I found my echoes were actually stronger on 2.3 gig than they were on 1.2 gig. And that has to do with as you go higher in frequency and you keep the same size of dish, the gain goes up. On EME, that goes out for transmitting and receive. So it means your echo to you is actually going to be stronger with the same power on 2.3 as it would be on 1.2. So, I mean, I was making single sideband contacts quite easily on 2.3 gig.
And there seems to be a constituency of people, or again, you're spotting yourself on a network so that people know you're there?
On Perigee, you can usually work somebody. I don't have to spot on 2.3. So I'd say there's active lists of about 50 people on 2.3.
Do you find that the Wi-Fi in your house stops working when you're transmitting?
No, but I bet my neighbors does.
Do you have to worry about the birds or anything like that if you're operating 100 watts or more?
They usually leave when I turn on the amplifier. So for some reason, I don't know why they do that, but they tend to leave when I do that. No, I move the antenna, so there's no dead birds or anything laying around.
Is there life on Mars, and can we bounce a signal off of it?
I think people's tried. I'm not sure it's been confirmed. What is that, 23 light minutes away?
Yeah, so the echo would be a while.
Yeah, it'd be a while. I don't know if any amateurs has done it, but I've heard of people trying.
Right. I saw a slide on a presentation that you made where you asked if there was life on Mars, and so I was just curious whether or not you'd actually knew anybody that had tried it.
No, I don't. I've known people who said they did try it. They didn't do very well on the outcome.
Now, do you do other bouncing modes? You said you did a little bit of meteor scatter. Do you do like aircraft scatter or anything like that in these bands?
When I first got on 5.7 gig, which was also 1985, and I wasn't on EME at that time, there was a local group here, W5UGO, K5 PJR, another fella, I forget his call. They got together and they were doing some 5 gig terrestrial stuff. And I thought, well, that sounds actually kind of interesting. I mean, it was way out there because now we're dealing with waveguide. I had no idea what waveguide did. So I started studying what waveguide did and made some own waveguide transitions and stuff, some waveguide filters. And again, they had the test equipment I didn't at that time to tune these filters up. And we started making waveguide mixers and things. And with just 5 milliwatts and a 2-foot diameter dish, we were making 60-mile transmissions with just a few less than 10 milliwatts.
When you say terrestrial, that's point to point or bouncing off of a aircraft? Or
it's just you're past the point of line of sight, so you're getting some reflections off the ionosphere, whether it's just terrestrial inversions called ducting. Now, we did try some aircraft scatter, and we could hear that, but the biggest one was rain scatter. So we point our antennas into a rain cloud that was raining, and you actually hear the signal come up when it went through the rain, scattered off the rain. That was kind of interesting.
And can you do the same thing with snow clouds? They are rain clouds, but maybe you have so much snow in the dish that you're spending more time getting the snow out of the dish than...
Yeah, we never tried snow. It was usually some rain, basically a wall of rain. So you're not in the rain. The rain is at some distance from you, and you would bounce off it like bouncing off of a giant building or something.
Right. You're seeing the storm system, off in the distance, and you're bouncing the signal off of that.
Yes.
You have an article or two up on building horn antennas. What are horn antennas? And they seem to be quite large, some of the ones that you've built. What do you find about their properties that may be more advantageous over, say, a feed in a dish?
A horn antenna is a fairly old design. I believe Ewan did some when he's with MIT, or was it Harvard? Maybe in Harvard. But they've been around a while, and they're only about 50% efficient. So, and they're not any more efficient now than they were back then. But they have very low noise. So the noise temperature of a horn antenna is 5-10 degrees Kelvin. They're very, very low compared to a Yagi, which may be 60 to 100 degrees Kelvin. So your signal noise ratio would actually be a lot better with the horn, but you have to have a bigger horn to get the same gain. So if you took a 10-foot dish and you took a 10-foot square horn, they would have about the same gain. But you think about the horn, to have a 10-foot opening horn, the length of it may be 50, 60 feet long. So you can see that there was a lot more material to make this horn to have the same gain as this little 10-foot diameter dish. So you can see the efficiency is not quite as good, but the temperature of it is much better.
Well, I remember that AT&T, their microwave network that ran across America for long-distance telephone, I think they had horn antennas mounted sideways on the tower with an opening or something like that. It had a cover over it, but those were horn antennas, weren't they?
Yeah, those were horns, and you're right. They just go straight up to the flared port, and then you'd have a diagonal port that would actually redirect that signal out to the sign for the horizon.
It would be a reflector.
Yeah, a little bitty reflector in it, and I'm sure it's figured into the gain of it because the opening would be adjusted for whatever that taper would be. But yeah, they had. They're not bad. It's just a lot of mass. Nowadays, I think a lot of people don't use the horn that large, but just because how massive it is to hold it up in the air. So they use other techniques to send microwave data, either through a dish, or they might put a horn at the bottom of the dish of the tower and send the signal up and go off of what we call a fly swatter, something like that. It takes up less space, less mass.
I remember seeing one of these actually in the Colorado Rocky Mountains, where the telephone company office was down in the little town, and I don't remember which, whether it was Vail, Colorado, or something like that. They had a metal reflector up on the mountain, and they had somehow, I guess they figured the angle, so they bounced the signal off of the reflector off the mountain, and that went over the mountain probably to some other relay station. But it was actually kind of a cool thing. I guess when you're a ham, you're always looking for weird things like that most people probably wouldn't know. They're skiing down the mountain, they see this big steel billboard. They probably were wondering where the advertising is on it.
Yes, I've always wanted one of those. I do the same thing. I think, well, they're not using it. It looked better in my backyard, but you know how that goes. Things are quite heavy.
But your use of horns was really an experiment to see efficiency gain, how they worked over the other antennas you were using?
Yeah, I did that, and I wanted to get students involved. So I kind of turned into a class project. I kind of threw it out there. Let's come up with a design that we can do cheaply, and let's put one together. So the first one was a foam one using stuff that you get your local hardware store, for insulation.
Right, the foam board.
Yeah, foam board with aluminum backing. So we first took it, cut it up, tried it. It actually worked pretty good. And that was their project. And I think, well, you all are doing that project. I want to build my own now. So I got the arc weld, the TIG welder out, and tigged up a horn out of aluminum sheet. And then that way we compared a better build horn compared to this flimsy foam board. Really it was about the same if you consider the gain of both of them.
We will return to our guests in just a moment. Nuts and Bolts Magazine is a new sponsor and is an amazing resource for new and old hams alike. Click on the banner to get your online or paper subscription of Nuts and Bolts. A new way to show your support of the QSO Today podcast is to buy me a coffee. I consume gallons of coffee to create this weekly podcast. Invite me for coffee by pushing the yellow button, Buy Me a Coffee, on the QSO Today show notes page. And now back to our QSO Today. What was the KP4AO special EME event?
Oh, that was a project of several hams, primarily K1JT or Joe Taylor. He had a lot of dealings with Arecibo there in Puerto Rico. So a group of them got together. They had done it in the past, but I think it's the first one he was a part of. And I think it was, 2010, that time frame. And they announced they were going to put the Arecibo dish there in Puerto Rico together for a weekend or two on 432 EME. And so I told the students at that time, this was well planned out. We have several months. I want you all to build an antenna, and we'll fire up our big Yagi array, and we'll work them with our Yagi array, but I want you to see if you can pick it up with their small antenna. So sad to say that dish got tore up by that last hurricane they had through there, and I don't think they're going to put it back together. So,
oh, that's too bad. But were your students capable of receiving signals with handheld antennas that they made?
Every student heard the signal with their antenna.
Bouncing off the moon. And verified, I said, now take the antenna, move it away from the moon. Signal went away. So now, of course, it was several degrees of beam width there. I mean, they can go 20 degrees off of it and still hear it. But eventually they would stop hearing it, and it was proof in the pudding. You had to be pointing at the moon in order to hear the signal. Do you have a sense of whether that created some kind of excitement, ignition, perhaps, in their brains in terms of how exciting that potentially was?
Yes, because out of that group, I think 2 or 3 of those actually have done something with their amateur radio license.
We need to come up with activities that cause those neurons to fire.
Yes, that activity was very beneficial. Our ISS contact, I believe in 2016, was real beneficial. That attracted a lot of people in that weren't even in our electronics department, other departments in engineering technology, and that was they thought that was pretty neat.
So we need to do more of these hands-on demonstrations that, well, they're out of this world, potentially.
Right.
Is there a way to receive any Moonbounce signals now using a handheld antenna without having a dish the size of Arecibo?
If you have digital modes and a 12-foot, 13-foot long Yagi on 70 centimeter, you could, as long as you knew where to listen for them, so someone had to post where they're at. But if you had a way to do that, you should be able to hear some of the larger stations with a single Yagi.
It's my understanding that you like to build HF and VHF QRP rigs. What I liked about the picture that I saw is that I guess you're used to milling out aluminum blocks so that you can make a chassis that's a milled aluminum block for like you would use for a microwave project, even for a small HF QRP rig. Do you build a lot of rigs for HF, and do you operate HF?
I operate HF. When I do operate HF, it's usually just QRP. We do enter the sweepstakes once in a while, or maybe the 160-meter contest once in a while, but just casual communicating on CW, it's usually just QRP.
And do you take your rigs out into the field? Are you a SOTA operator or anything like that?
No, there's a flight of bumblebees. I believe that group is part of a thing there in July. I do go out on it once in a while. And there's the 5 days in May. I believe it's part of Dayton. I'll go and do something with it. But normally I stay here at the house and do that type of operating.
4 days in May. It's my favorite event in terms of if I'm going to America for the Dayton Hamvention, then I advise the QSO Today community they should go to the 4 days in May because it's a real blast in terms of getting to meet people that like to put their hands in the rigs and building stuff. Yeah, the stuff that you're building is beautiful. Are there reference designs that you're using for your QRP rigs?
Yeah, in the beginning, I was using, some stuff from Haywood, I believe it is.
Yeah.
Another one's Rick.
His disciple. Parenthetically, Tommy is referring to Introduction to Radio Frequency Design by Wes Hayward, W7ZOI, and by another book that Wes did with Rick Campbell, KK7B, and Bob Larkin, W7PUA, called Experimental Methods in RF Design. I'll put those links in the show notes page. What other designs are you designing your own?
Yeah, I mostly design my own stuff. I mean, now what I have not gotten into is a lot of the digital DDS chips and things like that. Usually, if I'm going to use a digital board, I'll use somebody else's digital board. But all the mixing, if I make a super hat, all of the IF section, audio, transmitter, all that stuff, I'll do on my own. I may use the oscillator from somebody else if I want to have a VFO capability. Other than that, I mostly just use VXOs.
Are these CW rigs or are they multi-mode?
No, they're all CW monoband.
And do they have a built-in keyer?
A couple of them do.
You have some other hobbies, and I just wanted to touch on those as well. Have we exhausted the amateur radio side?
I can't think. I mean, it's so broad and so many years that I think it's good enough.
So one of the things that you do is you do radio astronomy, and one of the things that you also do, I understand, is hydrogen line astronomy. Can you talk a little bit about what that means and how you do that?
Sure. In the early 90s, when I was building a lot of the equipment that I do on the side, I do that on the side along with teaching. I also, have a kind of like a side job building converters and LNAs and antennas. A person picked up on the LNAs and said, "Could you start building these for us?" And I said, "Sure." And that was Radio Astronomy Supplies, and the fellow that ran that was Jeff Lichtman, and that got me into the radio astronomy side of it. So I started learning a lot about astronomy and listening to hydrogen line. It's 1420.405 megahertz. And all you really hear is a bunch of noise. But if you have a receiver that can pick up, you can see the Doppler shift in the hydrogen line, which is kind of neat. And there's other things to listen to other than the hydrogen line. There's you can listen to pulsars down at 400 to 450 megahertz. There's methanol you can listen to at 6 gigahertz. So there's a lot of the little things you can listen to, but most people listen to hydrogen line not necessarily for listening for hydrogen. They just think that's more of a SETI frequency, search for extraterrestrial intelligence. So they just chose 1420 because that's everywhere in the galaxy, and they think that'll be like the telephone line to phone home per se.
This was the hope anyway for anybody that wants to see a great movie about SETI. I think Contact. The book Carl Sagan wrote, Contact, and the movie with Jodie Foster is a great movie if you're into that kind of stuff. Now, when you're making a hydrogen line telescope, essentially it's an LNB in a dish pointed straight up into the air?
Mm-hmm. Yes, just point to the air. You can look at, if I'm going to do cold sky to ground, I make sure that when I'm looking in the sky, I'm looking at something that's clear, then I can point toward a hydrogen source. Or if I'm going to do some tests where I look at the sun, so I'll do sun noise. I'll look at the sun versus cold sky. I don't do that much hydrogen line in my work. I build the equipment, but I use it mostly for testing. I can pick up Sagittarius. Heard it. It's just noise.
Are you using a software that, as it's running, that's kind of recording the sky as the sky is going over?
I do have a software that does do a drift scan, so I can do drift scans to see what that looks like as it's plotted through. But I mostly use that information to tell me how good my beam width is on my my dish, my feed horn. So I use it more of a test reference, and I actually look at the data.
So there you go. There's another reason to have a dish up with an L&B in it, is you can use it for all kinds of other testing.
Oh, yeah.
It also seems to me that you've done some electric car conversions, is that right? And drag racing in electric vehicles. Can you talk a little bit about that? Is that something that actually you also do in the community college?
Well, I'm searching. So anything I can do to draw attention to a student to get them hooked on electronics, I'm going to do that, whether it be amateur radio or cars or sound. I mean, I've got a group right now that's really into sound. So I helped them design a fourth order speaker to go in their car. One fella has 6 15-foot subwoofers in the back of their car in a fourth order design, hitting it with 20,000 watts. And he's hitting 163 dB of pure noise at 50 hertz. So if that's what it takes, I'll put my headphones and earplugs in, and I say well away with it. So
now, what's the advantage of doing it in the car? It's the closed environment.
Oh, these people are just audio people that want to drive around and irritate other people, with their sounds so loud. So, but it's kind of electronics because you learn about decibels and things like that. So.
I heard wrongly, or maybe I assumed wrongly, that the reason for all of the power is for those instantaneous high frequency or low frequency peaks that makes it sound like you're there versus the power for volume. The power amplifier is not for volume, it's for frequency response.
This is for burp. What these guys are doing is just a burp. They call it a burp. So they're just doing an SPL, sound pressure level. And I have a meter that measures SPL. I got the school to buy it. So we put it on the windshield and we measure usually there's just one frequency that you're tuned to. And it just depends on the car. Normally at around 50, 60 hertz. And they'll just blast this sound for a couple of seconds and see how high the meter reading you get.
Without being in the car, because potentially they could blow up.
Oh, they're in the car.
Oh, really?
These kids, they don't care. They're in the car.
They could blow out their...
I tell them that, but they don't care. So I won't do it. Yeah, I wear headphones and stuff when I'm with them, but they seem to not bother.
So these other projects, because I saw that you actually like to drag race. You talked about the Chevelle earlier. Are you still drag racing? Are you racing now? And what are you racing on?
Okay, I'm still drag racing. That was another project I got the students involved with. And we first took a Kawasaki 500, and it was an 86 500, FR 500. And we took the engine out of it, put an electric motor in it, put some car batteries in it, and put around campus. Oh, that was cool, right? That was cool. You're driving this thing. It only has, about 4 miles of mileage on it before batteries have recharged, but we're going someplace. We let that set for a year or two, and then I saw where some people were drag racing electric vehicles. I thought, we can do that. So we took that same VR 500. We took that same VR 500, and we started putting lithium batteries in it and everything else and getting it faster and faster and faster. When we finally got it, I'm the driver of it because I can't let students drive it because the school didn't like that idea. So I drive it. And we got up to 100 mile an hour in a quarter mile. And I thought that's fast enough and on that motorcycle. But I wanted to go faster. So I went ahead and purchased a full-blown chrome moly chassis, drag bike chassis, and put 2 forklift motors in it that ran on 36 volt. I'm hitting them with 300 volts. Rebuilt the comm bars, how they attach and everything on the brushes, so they wouldn't arc as bad. They are meant probably for less than 500 amps. I'm hitting them with 1500 amps, and so it does 0 to 60 in under 2 seconds.
Wow. Are these chain driving the wheels, or are these actually on the wheels themselves? They're
chain drive, so I've got two of them sitting next together in parallel. So that chain drives each other, and I got a master chain that goes to the back sprocket, 1 speed.
Wow, fast. The 1 speed is fast, right?
Yeah, 1 speed.
And how fast have you gone?
Over 135.
And you have insurance?
Well, I don't worry about that.
For your family?
somewhere down the line or something, yes. My wife don't go out and watch me anymore. I know that.
If I was your spouse, I wouldn't either. You're doing this on a quarter-mile track?
Yeah, quarter and eighth mile. I do both. So I do the eighth mile in under 6 seconds. And I do the quarter mile in 9 seconds.
And what kind of safety gear?
I got leathers on. I mean, if I fall off, I might have broken bones, but at least I won't be skinned up, I guess.
Well, I remember Evel Knievel, the leathers kept all of the bones in the same bag, every time he would crash. And he crashed a lot.
Yeah, he did. Well, I'm not jumping, so unless just something weird happens.
So electric motors then have a lot of instantaneous torque, and that's the reason that they just take off, right?
Right. I'm using DC series wound motors. So we haven't made the switch to AC motors yet. The AC motor would probably be more efficient, but I think the torque is higher out of the DC motor, at least the test. I have a little dyno there. I can dyno the motors and check and see what they're doing. But the DC motors, and I can rebuild the DC motors pretty easily after I trash them.
Do you have to do that frequently?
Oh, I go through brushes about every 20 passes. I'll disintegrate the path. The brushes will disintegrate.
What do you see that we could be doing better to attract new people into the hobby?
That's using amateur radio in a multifaceted. So let's say in the pits, if I have the bike in the pits, I say, hey, you know what, guys? If you have a ham radio license, I'll get you a walkie-talkie. You can talk to me while we're doing all this stuff. So I'm trying to use amateur radio as an aid to fish them in on these other projects. When we go ballooning, we put a amateur radio up in the balloon, and we go chase it. Guys, you can't do this unless you got an amateur radio license. So I try to encourage students to think of amateur radio license as a tool, or use it as how I got into it, which was doing experiments. We got to do something to get their attention to want to do this, and I think that's where it's going to really lie at.
Well, Tommy, it seems to me that you have the best job. I'm sitting here thinking, boy, I wish I had done all of this, because you have the facilities of the school. I asked you earlier before we started, is your electronics technology program at your community college, is it unusual in the United States? I mean, do you get together with a bunch of your teacher friends from other community colleges and talk about your rivaling electronic technology programs, or are you the lone wolf out there?
I know there's other schools that have really hit hard on the Arduino projects. So the ones I have talked to, they tell me they're taking their students that direction. We can go that direction too, but as far as I know, we're one of the few that's doing this stuff with the amateur radio and the electric motorcycle and the high altitude ballooning and the microwave. We try to do it all, so to keep interest up for students.
What excites you the most now in amateur radio?
I must still say it's EME. I like the EME the most, and I still like building the test equipment and the stuff that goes along with it. So building LNAs, building converters, hearing converter work, building an antenna and going out and pointing it to the moon to pick up a signal. Right now, I think that's still the most exciting part.
If you had advice to give to new or returning hams to the hobby, what advice would that be?
I would say that go ahead and get with someone that's older, that's done it already, and learn some stuff from them. And I know that they would be willing to give it to you. Get with your local amateur radio club in your city or school that's doing that, and just get on the air and try something. And there's nothing wrong with trying the digital modes if that's what you want to do.
Tommy, I want to thank you so much for joining me on the QSO Today podcast. I'm so glad that we had this conversation today. I learned so much, and it was such a pleasure to have you on the QSO Today podcast.
Thank you, Eric. I appreciate it.
73.
73s.
That concludes this episode of QSO Today. I hope that you enjoyed this QSO with Tommy. Please be sure to check out the show notes that include links and information about the topics that we discussed. Go to www.qsotoday.com and put in WD5AGO in the search box at the top of the page. Be sure to click on the Expo menu item at the top of the page for updates on the upcoming QSO Today Virtual Ham Expo. We already have presentations and speakers posted. I'm updating this as I have more information. My thanks to ICOM America for their continued support of the QSO Today podcast. Please show your support of this fine sponsor by clicking on their link in the show notes pages. You may notice that some of the episodes are transcribed into written text. If you'd like to sponsor this or any of the other episodes into written text, click on the transcribe button at the top of the show notes page. Support the QSO Today podcast by first joining the QSO Today email list by pressing the subscribe buttons on the show notes pages. I will not spam you or share your email address with anyone. Become a listener sponsor monthly or annually by clicking on the sponsor buttons on the show notes page. By using the Amazon link on the home page before you shop at Amazon allows Amazon to send us a small commission on what you purchase that further keeps our QSO Today project going. I am grateful for any way that you show appreciation and support. It makes a big difference as we work towards episode 500. QSO Today is now available on a large number of podcast players and now a host of podcast services and applications. We are Podcast 2.0 compatible. I now use the Fountain podcast player to listen to all of my favorite podcasts. Until next time, this is Eric for Z1UG 73. The QSO Today podcast is a product of KEG Media Inc., who is solely responsible for its content.